Okay. Okay, anyone who can answer my simple question?
ma'am.
Pentene? Pentene, Arnel?
Yes, ma'am. 1
One pentene. So let's say we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then you have this one, tama?
Yes, ma'am.
Okay, and the next, what will be our reagent? Will I ask? Kasi pwede na itong reagent ani SARC Seminis Program Representative. Kinsa man ni? Si Camille. Camille ba ni? Can we call SARC? What will be our reagent here? SARC.
Hello, ma'am. Kuan, ma'am. DHR, ma'am, of THF, ma'am.
Okay, you can have your one. You have your BH3 in the presence of THF. And the second one is
H2O2.
your peroxide in basic medium. Okay, so if you have that, you can actually add your anti-Markovnikov addition. And this is where your BH3, you have your BH3. This one will be added here, and this one will be added here. And then you will get your 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and you will get your BHH, and then your hydrogen, right? And then of course you have that followed with H2O2 and OH, and you will get your kani, ma-replace na siya with OH. 2, 3, 4. You have your OH, right? Instead here. So it follows the anti-Markovnikov's addition. If you just use an acid and water, so dili siya, you couldn't obtain your 1 degree 1, 2, 3, 4 pentanol. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so you just have to be careful. This is anti-Markovnikov's addition. Of course, you need to have 3 moles of this, not to get your alkyl, and of course, but you have your product here. Okay, so it's very simple, the hydration process. So, and the rest of the problem set I will upload that you can work on the weekend or later. So we can still have 2 meetings next week. We'll meet on Tuesday and we'll meet on Friday. The exam week for the chemistry is, I think, on Friday. And we'll use on the exam time so you can still discuss or continue with chapter 8 before we'll have our exam, which will be a week after next week, which will be Monday or Tuesday. Okay, before we end, we have another problem. Solve problem. Show how you can synthesize 2 phenyl you have here from 1 phenyl ethanol here. Okay, so you notice that you have 2 carbons from phenyl here. You have here 2 carbons here. We get your OH and then here. So can you suggest how do we synthesize this 2 phenyl ethanol based from here? Sa itong reagent gamiton. Anyone? It's Shaira. Two carbons, you have your OH. Yun sa nga pagbalhin sa OH. No, it's just like a puzzle. Yun sa kanya. You have to remember now, once you get your product na OH, once may starting material, usually you get your starting material from an alkene. Tama? Once you get your OH, di ba? You can always get your alcohol from an alkene. It's simply just a hydration reaction. So of course you have to find a way before you get this one, you get the retrosynthetic approach. You have here, to have your alcohol here, it should come from an alkene, right? An alkene for which you get your alcohol. But so you have to have a starting material before this one, a precursor, which is an alkene. And how do you get your alkene decandirea? Okay. So of course you've learned on how to prepare your alkene in chapter 7. To prepare an alkene, you can start from an alcohol using the dehydration process. So you can have your OH here to be dehydrated by the presence of your acid. You can dehydrate your OH and water and hydrogen to dehydrate, eliminate water. You get your alkene. Once you get your alkene, then you can add your HOH decandinia. So if you have convert this one to an alkene, you have your double bond here. So your hydrogen can be added dire or direa, depending kung Markovnikov or non-Markovnikov siyang addition. So if your hydrogen is added direa and OH is here, that we follow the Markovnikov's addition. If your hydrogen is added direa and you have your OH here, it follows the anti-Markovnikov's addition. Okay, it's very simple. Okay, tama? So you'll have more problem set for that. I think natin pangutana di ay last time, no? I don't understand. Or natin pangutana last time. Yung problem set. So you get an alkene. So katong akong giganti ganina from this, you can do the retrosynthetic approach from this. What will be your precursor before you get this? Before you get this one, of course, you get your alkene, and your alkene will be your precursor. Before you get your alkene, of course, you get your alcohol. You can have your dehydration process because we have here. So first one, you have to get from the retrosynthetic approach. Kani siya, no? Kani diri ta magsugod. Diri ta mag retrosynthetic kani diri lang ta. So before kani siya, unsay asa ni siya pwede nimo makuha. Okay? It can be made from this one, okay, and this one can be made from here. So kani can be made from this, kani can be made from this. So kani can be made from here, kani can be made from this one. Right? So you have your kani alkene. So you can start here to get there. And the reagent that you need is simply your acid, and you heat it. And so the dehydration process, you get your alkene. Then the next one, this is the anti-Markovnikov. This is the one that I have mentioned earlier. You have your double bond. Your HOH is added anti-Markovnikovs. If it's Markovnikov's addition, your hydrogen should be added here and OH should be here, but this is not the case. It follows the anti-Markovnikovs. So what are the agents that follows the anti-Markovnikovs? You have your BH3 in the presence of your peroxide. Okay, BH3 in the presence of ether and H2O2 in the basic medium. Okay, so this is your agent. First step, your second reagent here, you get this product. Okay, so it's very simple. In summary, the alkene hydration methods. So the first one, there are 3 methods for the hydration methods of alkene. When you say hydration, we add water to our alkene, and the process will actually, we get our alcohol as our product. Now, baliktad, when we prepare our alkene, we prepare that one from alcohol. In this case, we have our alcohols obtained from our alkene. So the first one is the acid catalyzed hydration of alkene. It follows the Markovnikov's rule, but it may lead to a mixture of constitutional isomers. If the carbocation intermediate, the reaction may undergo rearrangement to a more stable carbocation. Okay, so since we obtain a carbocation here, you have to discern, no? Can we get still a more stable carbocation? Could there be a rearrangement? Could there be a metal shift or hydride shift that would lead to a more stable carbocation? And then we will be led to a different alcohol. And the second one is the oxymercuration, the mercuration process. And this one, it still follows the Markovnikov's addition, but this one is the often preferred choice over the acid catalyzed acid catalyzed hydration of Markovnikov's addition nga naman, there is no complication, there is no rearrangement, unlike kaning sa acid catalyzed hydration. So we can easily predict kung sa atong gusto nga product, we can easily predict kung sa atong product because there is no rearrangement that happens with oxymercuration, demercuration. Again, you have here oxymercuration, demercuration. There are two sets of different reagents that's being needed to get our alcohol here. And the last one is the hydroboration oxidation process. It follows the anti-Markovnikov's rule of addition. And there is a synhydration from our alkene. And of course, there's two sets of reagents. So the first one is hydroboration reagent. The second one is the oxidation process to get our alcohol. Okay, and in summary, for the acid catalyzed hydration, your condition, of course, you have your acid, which acts as our catalyst, and our water, which acts as our nucleophile or base. No, it will abstract. Okay, you have your water. This is addition of your water to your alkene, and it follows the Markovnikov's rule. The stoichiometry is not controlled, and the occurrence of rearrangement is rather frequent. Okay, so you just have to be careful when we're doing the acid catalyzed hydration process. There could be a rearrangement that would lead us to a different alcohol than as predicted by the Markovnikovs, by the carbocation. So you have to discern whenever you get your carbocation. You have to ask whether it's possible or not to have a more stable carbocation. The second one is the oxymercuration demercuration process. You have reagent, mercury acetate in the presence of THF, and of course, the other agent is water. This is the one that the OH will be added once to the double bond. So in the process here, the first carbon from the double bond will add to mercury, and the second carbon from the double bond will have your OH. And it follows the Markovnikov's addition, and the mercury, alkyl mercury, can be reduced by sodium borohydride to get our for the mercury, alkyl mercury to be reduced to mercury, and then you get your hydride lang added. And this one follows also the Markovnikov's addition, and there is no rearrangement here. You just have to be careful. Sometimes here you can also substitute water with methanol or alcohol, and in that case, instead of an alcohol, you get an ether instead of an alcohol. Okay, and the last one is the hydroboration oxidation process. You have your BH3, THF, and H2O2OH. It's two-step, and this anti-Markovnikovs, and there is the stoichiometry is very controlled, it's very specific, and there is an addition of H and OH here. And rearrangement also is very seldom. Okay, so just still have 5 minutes. Just remember, there's just a case where you can have the protonalysis of alkyl bearings before we end. Also, what is the protonalysis of alkyl bearings? Once you get your alkyl bearing in the hydroboration process, the last one in the hydroboration process. Now, once you get your alkyl bearing, it's possible that we can protonate or alkyl here. So how do you get that? We heat the alkyl bearing with acetic acid, H3COH, and it causes cleavage here, and you get your alkane, and substitute the R with the acetate here. So the protonalysis of alkyl bearing takes place with the retention of configuration. Whatever the configuration of your R here will be the same. It stands. Hydrogen replaces boron. Okay, here, whatever the stoichiometry of boron here will be replaced with hydrogen, and there will be retention of configuration. And the overall stoichiometry of hydroboration protonalysis is again same, just like the oxidation of alkyl bearing. The hydroboration followed by protonalysis of the resulting alkyl bearing can be used as an alternative method for the hydration of alkene. So you notice here that the product is an alkane. Okay, so if, for example, you want your product to be alkane, Yeah, simply have to start. You simply have to start with alkylbutane and you can actually obtain your alkane. Okay, so this is like a side reaction once you get your alkylbutane. Instead of doing the oxidation with hydrogen peroxide and hydroxide to get your alcohol, OR, and then you get your alcohol in the presence of hydroxide, you can also have a side reaction if you use a different reagent. Instead of the oxidation, you get the protonolysis of alkylbutane to get your alkane. Okay, so problem, this one usually, so again, the hydroboration process, hydroboration followed by protonolysis is an alternative to catalytic hydrogenation to obtain your alkane, which is a more common procedure. And the reaction of alkylburanes and deuterated triated acetic acid provides very useful way to introduce these isotopes into the compound in a specific way. As you have here as an example. Okay, so once you prepare your alkane, there's two ways to prepare your alkanes. You have the hydrogen addition to your alkene, or an alternative to that is this protonolysis of your alkane. You just use an acetic acid and heat, you get your alkane. So if you remember in the previous chapter, your chapter 7, no? In one of the reactions of your alkene is it chapter 7 or chapter 8? Can't remember. It's one of the reaction is that you can add hydrogen to your alkane and you get your alkene. So that ends our lesson for today, and I will send the practice problem set for which you can work for this weekend and next week. And next week we'll continue. Okay, that's all for today, and just don't forget to indicate your attendance. And I will send a survey, no, to your class. A survey if you can attend the next week. Your class is included, no, for the laboratory lang. Is included for the face-to-face simulation. Of course, the university will fully open for the face-to-face setting on the first semester. But so for now, the stage is simply a simulation of what will happen if the students would come into their class. But what will be open is just for some of the laboratory courses. So your course is one of those that will be included, and I still have to think what activity you will be doing for the Wednesday. But for me, it's very alangani, no, it's on Wednesday because pagka-Thursday yan, it's already an exam week. So if you are from Butuan lang or the silingan nga mga towns sa Butuan, it's easy for you to come to the university, right? But for others, so that's why I have to send a survey questions. If you can answer, so I would know the status if you can come or not. And only those vaccinated students are allowed to join the laboratory class face-to-face. Okay, if you have no more questions, that ends our session for today. See you next meeting, and just wait for my message or survey link. Okay, so that's all for today. And if you have questions, I think you have questions regarding your problem set. You just have to follow no kadok na post nga i-indicate nga mga problems. So na question. Okay, and we'll continue to upload another problem set for you to study more on chapter 8. Now, for you to study more, I would really encourage you to answer in advance the end chapter problem sets that is from your textbook. And that is the only way for you to really be confident in organic chemistry, for you to practice, even if we understand in the discussion, no, but we need to have our motor skills involved. We have to need our pen and for us to obtain our product from our reactions nato. And that will be in preparation once you, of course, do your exam pohon, once you finish your program chemistry. If you want to take the board exam, no, usually what we do is we answer all the problem set for each chapter, from the general chemistry to the organic chemistry. No, that's the only way. If you can do that, like answering you back to back every chapter and chapter, you can be very sure that you will really pass the exam in the near future. And you can really be sure that you get a perfect, almost a perfect score, or a perfect score for organic chemistry. Okay, so I believe in you guys. Hopefully you can put more effort for you to study more on your organic chemistry courses and other courses in chemistry as well. So that ends our session today. I'll see you next meeting. You have no more questions.